Hello everyone, myself Shinde V.G. working as Assistant Professor at Department of Nanoscience and Nanotechnology, KTGM College, Nasik. Today we are going to discuss the class of T.Y.B.Sc semester 3rd, paper number 2nd, that is the course of Nanophysics. Now we are going to discuss today's lecture the topic of Gaussian distribution probability functions. In this topic, I have covered the expression of Gaussian distribution function and the example or problem of Gaussian distribution function. Now, we have covered the first one, Gaussian distribution function. The other limiting form of binomial distribution is the Gaussian distribution, which is the most important distribution in statistical mechanics. Means the limiting form of binomial distribution. Means Gaussian distribution and binomial distribution is also same, but the limiting form means particular limit of the Gaussian distribution function, which is the most important distribution in statistical physics or statistical mechanics. This distribution becomes valid when capital N is large and small n also is large, but not too close to capital N. Means this distribution values become when capital N is large and small n is also large, but small n is not too close capital N. This distribution is known as Gaussian distribution. It can be shown that the binomial distribution. It can be shown that binomial distribution. In binomial distribution, formula is also known as the Pn, means probability of n particles or n events is equal to capital N factorial upon small n factorial in bracket capital N minus small n factorial p raised to n q raised to capital N minus small n. That is the equation number first is a probability equation or the binomial distribution equation. Okay. Tends to exhibit a maximum when capital N is large. This condition when are valid from the capital N is large. For large value of small n, the change in Pn when small n changes by unity is very small. Therefore, Pn as a slowly varying function of continuous variable small n. We shall deal with ln Pn since it is a much more slowly varying function of small n. But that is the deal with ln means logarithm form of the binomial distribution functions that have calculated or written as the ln Pn is equal to ln in bracket capital N factorial upon small n factorial in bracket capital N minus small n factorial p raised to n q raised to capital N minus small n bracket complete. This is the also written as ln capital N factorial minus ln small n factorial minus ln in bracket capital N minus small n factorial plus n ln p plus in bracket n minus small n ln q. That's how in this bracket term we have separate written here. Capital N factorial ln capital N factorial. This is the numerator term. This is the written as, and denominator term ln n factorial is written here minus sign and also written ln in bracket capital N minus small n factorial. This is the also written by the minus sign and plus sign. Why? into terms. Okay, into terms. That's why the n means raised to power. Ln is that's written first. Raised to power is written first, and ln p, and that also quantity. This quantity is also written as capital N minus small n ln q. Using Stirling formula. In this equation, we have using the Stirling formula. Using Stirling formula. We have Stirling formula used in this equation. That's how ln Pn is equal to. That's the factorial term are written by the n is first one and minus n. Okay, minus term written are also here minus. That's have the positive plus sign here. Okay, the nn factorial is written by using the Stirling formula. That's how n ln n means capital N ln capital N minus capital N minus small n ln small n plus small n minus in bracket capital N minus small n ln in bracket n minus small n plus capital N minus small n plus n ln p plus in bracket capital N minus small n ln q. That's how here the minus capital N and plus capital N is also get cancelled, and here capital small n and minus small n, this is also the cancel. We have this term is written as capital N ln capital N minus n ln small n minus in bracket capital N minus small n ln in bracket capital N minus small n bracket complete plus small n ln p plus in bracket capital N minus small n ln q. This term by differentiate with respect to n. This equation by differentiate with respect to n, we have this written by d upon dn ln p is equal to minus n ln n minus 1 plus ln in bracket capital N minus small n plus 1 plus ln p plus minus ln q. Here the minus 1 and plus 1 get cancelled, and this term we have also written as ln is common. That's how in a bracket capital N minus small n into p. This is the positive term written by the numerator and the minus term is written by the denominator. Okay, this equation is second. For Pn is maximum, probability of Pn state is a maximum. That's how also written by the ln in bracket n minus small n p upon nq is equal to 0. That is the also written by in bracket n minus small n p raised to e upon nq is equal to 1, or also written by capital N minus small n in bracket p upon n in bracket 1 minus p is equal to 1. That is also written by small n is equal to capital NP. That is the equation number 4. We have, let us investigate the behavior of Pn near its maximum value. That's how also assuming that the n minus mean value n to be very small. we expand in Pn in a Taylor series about the value of mean value n as ln Pn is equal to ln P mean value n plus in bracket d by dn ln Pn bracket complete another bracket n minus mean value n bracket complete plus 1 by 2 factorial in bracket d square upon dn square ln P in mean value n bracket complete in another bracket n minus mean value n bracket square plus dash 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 is the Taylor series. Okay. We may neglect higher power since the n minus mean value n is very small. This Taylor series, we have neglect the higher power. That's how the n minus mean value n is a very small value. Okay, is a very small value. That's how now from equation second at n is equal to mean value n, we have calculate d by dn means differentiate of ln Pn is equal to 0. We have also written by and 2 times differentiate that ln Pn is equal to minus capital N upon small n in bracket capital N minus small n is equal to also written by capital N upon capital N small p in bracket capital N minus small p. That's how calculated by the n small n is equal to capital NP. This value is put up here is equal to minus 1 by capital NPQ. We have find out that the dual differential, that's the ln Pn equation. Okay, we have also written hence ln Pn is equal to ln P mean value n minus in bracket small n minus mean value n bracket square upon 2np. That's the written here, or also written by Pn is equal to P mean value n e raised to minus in bracket n minus mean value n bracket square upon 2 capital N P Q. This is the equation number 5. That's how this equation is written by here. The value of P mean value n can be found from the normalization condition. We have this value means P mean value n. This value is find out that the normalization condition by used. This value is here summation over Pn is equal to summation P mean value n e raised to minus in a bracket small n minus mean value n bracket square upon 2 capital N P Q is equal to 1. This equation we have put up the x is equal to n minus mean value n, and replacing summation by integration we have written by summation over Pn is equal to integration over minus infinity to plus infinity P in bracket mean value n e raised to minus x square upon 2npq dx. Okay, this equation is written by here. Okay, that's how let y is equal to x upon under root 2 capital N P Q is put up by the y is equal to, therefore summation over Pn is equal to P mean value n integration over minus infinity to plus infinity e raised to minus y square, means this value put up here y or y square, y, that's have the y square, x square, this term we have written by y square under root 2npq dy, means this equation is differentiate that's how this value is formula. There, that's the dy is equal to 1 by under root 2npq into dx. We have this value into upon term, that's how replace here under root 2 capital Npq dy is equal to dx. This value is put up here, this dx value put up here. Okay, now to simplify that, this equation is P mean value n under root 2 npq under root pi is equal to 1. Therefore, P mean value n is equal to 1 by under root 2 pi capital Npq. This value is a mean value. This is the P mean value n equation by find out that, and the Pn is equal to 1 by under root 2 pi capital Npq e raised to minus in bracket n minus capital Np bracket square upon 2 capital Npq, that is the equation number 6. This expression is easier to evaluate since it does not involve factorial of large numbers. This expression does not involve factorials of large number. This is the Gaussian distribution function. Topic is over. The one of the example is, or one of the problem is studied here. Example or problem is, a vessel of volume V is mensually divided into two equal parts. The vessel contains 6 molecules. Calculate the probability distribution using binomial and Gaussian distribution formula. Depicts the result obtained in the two causes graphically. Means this find out distribution by the graphically represented. Okay, in here a vessel of volume V is divided into two equal parts. Two equal parts means P or Q is equal to equal, that is equal to 1 by 2. Okay, and the vessels contains 6 molecules. Vessels contains 6 molecules, means capital N is equal to 6. Okay, then find out that the binomial and Gaussian distribution. Okay, first we have written the given term. The probability that a molecule is found in a left half is obviously 1 by 2, that is the P is equal to Q is equal to 1 by 2, and 6 molecules we have written capital N is equal to 6. We have also the, by using binomial distribution formula is written here. The probability of binomial distribution is Pn is equal to capital N factorial upon small n factorial in bracket capital N minus small n factorial Pn Q raised to capital N minus small n. This formula is used that the find out or calculate the probability distribution, and also use the Gaussian distribution formula is Pn is equal to 1 by 2 under root 2 pi npq e raised to minus in bracket n minus capital N p bracket square upon 2 npq. This is the formula by using that, and find out the probability distribution by using Gaussian formula. This is two formulas first one and second one formula are used, that these we have calculated that the students. Okay, we have here state n is equal to first column n number of states. Okay, second is binomial distribution Pn and Gaussian distribution Pn. In here n value is 0, that's why the binomial distribution formula are used. Pn is equal to capital N factorial upon small n factorial in bracket capital N minus small n factorial p raised to n q raised to capital N minus small n. This formula or this distribution formula are used, then find out n is equal to 0. That's how this value is find that. Is also Gaussian distribution formula are used, that the Pn is equal to 0.0162, means these two value is approximately same, but there are different values. The binomial distribution and Gaussian distribution, we have the different values. That's how the n is equal to 0, the binomial distribution value or answer is 0.0156. Okay, that's how also Gaussian distribution by n is equal to 0, that's how the answer is 0.0162. And also the n is equal to 1, the binomial distribution is 0.0937. That's how the Gaussian distribution is 0.0858. And the n is equal to 2, we have calculated that the binomial distribution is 0.2343 and the Gaussian distribution is 0.2333. That's how the for n is equal to 3, we have calculated that the value of 0.3125 and the Gaussian distribution value is 0.3157. And the for n is equal to 4, that's how calculated that the binomial distribution value is 0.2343, means the 4 number value and 2 number value are similar, means these value are curved that. Okay, highest value, these two values are highest and peak is downward direction. That's how for n is equal to 4, binomial distribution value is 0.2343 and the Gaussian distribution value is 0.2333. And also find out that n is equal to 5, we have also calculated that 0.0937 and the Gaussian value is 0.0858. And also n is equal to 6, we have also calculated 0.0156 and the Gaussian distribution value is 0.0162. We have these two columns. I have calculated that the graphical representation. Okay, graphical representation. The glance at the table and figure shows that the event at such a small value of n and small m. The results obtained are very close. For the large capital N is difference becomes still insufficient. This the graphical representation here. This is the value 0.01, 0.02, 0.03 and the n value here. That's how n is equal to 0. This value written here. Okay. In here the 0 and dot. This is the binomial distribution. Okay. Point is here the binomial distribution and cross sign is a Gaussian distribution. This is the cross is Gaussian distribution values. Okay, this is the graphically represented that. In today's lecture, I have discussed the expression and definition of Gaussian distribution function and also find out the mean value of Gaussian distribution function. And one of the problem I have discussed by the comparing to binomial distribution and Gaussian distribution. These two distribution formulas are used and find out the answers, and this answers is tabular form written by, and this comparison is graphically represented that. In next lecture, I have discussed Poisson's distribution function. Thank you.